Okay.
Okay, ready? Okay, hi, my name's Heather Rule. I'm a chemical engineering undergraduate here at the university. You might remember a couple weeks ago I talked to you about the future of vehicle transportation. And I started off, or I ended it with saying that I wanted to look into hydrogen-powered vehicles as a way to solve our current vehicle problems. And what I'm going to talk to you today about is how hydrogen-powered vehicles work. They're very different from your standard internal combustion engine. I don't know how much most of you guys know about internal combustion engines, but they're pretty simple when you look at it. And that means that basically all you have is a cylinder with a piston inside. This piston is attached to a shaft which can move up and down to do work. Into this cylinder, you put gasoline and oxygen, which comes in as an air intake, so that's just regular air that we're breathing in and out now. You spark it, and that expansion, that combustion reaction, expands the gases, which pushes this piston down. And that's what allows your car to move forward. Now, a hydrogen-powered vehicle isn't really anything like this. In fact, it's more similar to a battery-operated car than it is to an internal combustion engine. Now, that might seem weird since you go, well, we're going through this chemical reaction. This looks like it might be somewhat similar, but it's not. So, a standard battery operates a little bit differently. So the thing you have to think about is in a battery, you have a set amount of chemical potential. The amount of chemical potential or electricity you can get out of a battery is standard. You're not adding chemicals, you're not subtracting chemicals, and that means that eventually the battery will die. We've all gone out on that one morning that you're in a rush, tried to turn your car on, the battery's dead. In a hydrogen-powered vehicle, that can't happen. And the difference is the fact that you continuously have chemicals flowing in instead of a set amount. So we're just going to quick drop a schematic of what a hydrogen fuel cell looks like. And this is a simplified version, but when you large scale it, it's pretty much the same. We're going to split it into 3 equal parts with 2 pillars in between. On one side, we're going to have hydrogen coming in from our fuel tank. In the middle, we're going to have a catalyst and an electrolyte. On the other side, we're going to have oxygen coming in, again from an air intake similar to that of an internal combustion engine. Now, we're going to go back to Physics 202 for those of you who have taken it, and we're going to talk about these pillars. This pillar on this side is an anode, and this pillar on this side is a cathode. That means that you've got a negative side and a positive side of an electrical circuit. This is attached to something, an electric motor, generator, what have you, that allows you to do work. Now, the important thing is that this is a catalyst. That means that this catalyst makes this hydrogen really want to react with this oxygen. So these two really want to react. But you also have an electrolyte. And the electrolyte makes it so that only positively charged ions can flow through it. So in order for this hydrogen to react, it needs to lose its electrons and become a positively charged hydrogen to go over and react with the oxygen. But what happens to the electrons? This is where we get the electricity or current flow. The electrons have to travel around the circuit, and this is where we get our current, which allows us to do work. The electrons eventually will make it all the way over to the other side, where they'll allow the hydrogen to react with the oxygen and form water vapor, which is then exited out of the vehicle. So, in conclusion, when you think about a hydrogen-powered vehicle, you shouldn't think of an internal combustion engine. You should think of it more like an electric battery-powered vehicle. The difference being that at the end of the vehicle's life, you do not have a battery to dispose of, making it more environmentally friendly. So again, same electric circuit, very similar to a battery, but no waste at the end. Thank you. Can I have any questions? Yes.
How easy is it to put hydrogen into the car, like compared to like gas?
So hydrogen is actually, there's a funny clip on a TV show where they actually talked about in Europe they're actually using hydrogen-powered buses. So think of public buses that are hydrogen-powered. And the host goes around looking at how you fill it up. And it's literally the exact same, only you have a seal instead of, your normal gas nozzle. So because it's a gas, you need to seal it correctly. But other than that, it's the basically, from a user standpoint, it's the exact same thing.
How does the hydrogen flow through those like pillars? Would they be like permeable or?
Yeah, so they're actually, and like I said, this is a little bit simplified, what these actually are is, they're more like curls, they're more like loops that go back and forth. So they're not, you know, solid, if that makes any sense. So there is space in between them for things to go through. Does that make sense?
Yeah.
And I know it's, like I said, this is a simplified version, that it's not like a, you know, a solid thing. It's solid in an S shape, if that makes sense.
The way the hydrogen enters the first chamber, is it similar, like, do they use sort of like a fuel injector like they do in an internal combustion
Yeah.
engine? Or is it
It's
something
more
different?
similar, yeah, and that's where you kind of get into, it's kind of similar to an internal combustion engine, that you do have constant flow. The
Okay.
difference being that, I don't know how much, but you don't have a V8 with 8 pistons that you're,
Right.
you know, pushing gasoline into each individual cylinder. Instead, it's more of a constant flow in, and then if there's any waste or any hydrogen that doesn't react, flow out process.
Okay,
So similar, but not exactly, because it is a gas.
gotcha.
This is slightly tangential, I know that's not a huge problem, but where is this hydrogen usually coming from?
So that's a little bit tricky, and that's the biggest problem with using hydrogen-powered vehicles. There's a few different ways you can get it. The first one being from gasoline or oil that's drilled. The second one is you can actually do this whole process in reverse, only instead you input electricity, and instead of starting off with, you know, hydrogen, you actually start off with water, and then you end up with H2 and O2. Does that make sense?
Mhm.
So instead of getting electricity from it, you have to do it reversibly. It would be possible, and if you want to do a renewable resource, you would be able to power it through solar power, is actually what was recommended by one of the professors at the engineering research building, or the engineering research center. So it is possible to do it greenly, it's just a little tricky.
Gotcha.
Anything else?